In lesson 3, we're going to look at rational functions. Again, this is the polynomial and rational functions pi, slice, and alex. So we're going to look at finding the intercepts of rational functions, horizontal, vertical asymptotes, how to find slant asymptotes, domain and range, and how to sketch them. First thing to talk about is what is an asymptote. So an asymptote it's a line that a function approaches but never actually gets there. It gets close enough that we can say, okay, it equals that, but it never actually gets there. So the way you can think of an asymptote is in football terms. Okay? When a penalty occurs, one of the things you can do, end zone. And so say this is the 40-yard line right here. They can say, okay, half the distance to the goal is the penalty. So then you're going to go to the 20-yard line. Oh, penalty happens again. You can then go to the 10-yard line. Oh, penalty happens again. You go to the 5, so on and so forth. The penalty will never put you into the end zone. That's the asymptote. You can keep getting closer and closer, but you will never get there. Now, in the football analogy, hopefully at some point someone will push the ball over the end zone and in and score. But mathematically, doing halves like that, you'll never actually get to that point. So let's see what that looks like. So here's another picture thinking of asymptotes. We can have a vertical and a horizontal. And the horizontal doesn't always have to be horizontal. It could be at an angle, which is where we get slant asymptotes, we'll talk about that in this video. So vertical asymptote. So your vertical asymptote, we've already looked at a little bit when we first looked at rational functions, because we talked about what your denominator couldn't equal. We talked about it as a domain restriction. Well, that domain restriction graphically ends up being a vertical asymptote. So if we look at this one quickly, we can factor out the 2. We end up with x squared minus 4x plus 3. So this factors into 2x minus 3, x minus 1. And then that's all divided by x minus 4, x plus 1. Okay? So it factors into. So in this case, we end up with 2 vertical asymptotes, one at 4 and one at negative 1, because that's what makes the denominator 0. So here's some linear ones that I'll work out in class. So as you have questions, you can ask me, and these are a little bit easier. Okay. Once we have the vertical asymptotes, we have horizontal asymptotes. Now, the horizontal asymptotes are a little tricky. So a rational function, you can only have one. Okay, because if you think of a graph, and if you think of something having a horizontal asymptote, that means that some part of the function approaches and stays, and some part of the function approaches and stays. Or there's a function approaches and stays. It still passes the vertical line test. If you think there's another one, that would imply that something's going on in here, and then something's going on in here. It means it's not a function. So you will have at most one horizontal asymptote. Okay. The asymptote, we look at the degree of the numerator and the degree of the denominator. So for example, if I have x over x squared, the degree of my numerator is 1, and the degree of my denominator is 2. This is n, this is m. If n is less than m, your horizontal asymptote is going to be y equal to 0, is going to be your x-axis. Okay. If they're the same, so for example, x squared over 2x squared, your horizontal asymptote is, you look at your coefficients. So in this case, we have 1x squared over 2, so it's 1 over 2. So our horizontal asymptote is 1/2. And then our third option is if n is greater than m. So let's say we have x cubed over x squared. There's no horizontal asymptote in that case. And if you think about it, that's because these will cancel. In this simple example, those will cancel, and you'll just have x. So there'll be no need for an asymptote. And the same is true for more complicated functions. So for the sake of the length of the video, I'm not going to do these in the video. I may put out a second video that's just me working through these. So that'll be listed below in Canvas. So we're going to look at a slant asymptote. Slant asymptote uses something that is not used all that often, and you probably haven't seen it before, but it's polynomial long division. And in essence, it's the same as doing regular long division. We're just doing it with variables. So we're going to write it neatly. So we're going to take 3x plus 9. And inside we have our 2x squared plus 9x plus 3. So the first thing you're going to do is you're going to take this term divided by this term and put that up here. So this spot up here is going to become 2/3 x. Now, just like we would with any polynomial, with any long division, we take this and multiply it by that. So you're going to end up with 2x squared, and then it's going to be plus 18x over 3. So, and then, again, remember from long division, you subtract. So this is 0. It's kind of like elimination. And this 18x over 3 simplifies to 6. So you end up with 3x. Okay. You do the same process again. So we're going to add 1. So we get 3x plus 9. And we subtract, so we get 0. And then minus 6. So once we get down to here, -6 is our remainder. We don't care about the remainder. What we care about is what we have up here. So y equaling 2/3 x plus 1. This is our slant asymptote. So that's going to, in our ordered pair, we'll start y-intercepts at 1, and then it's up 2 over 3. Actually, instead of usually your asymptotes are dash lines, and then your function does whatever it does up to that asymptote, but never crosses it, never actually touches it. So that's slant asymptote and polynomial long division. We'll go over that again, and we'll talk about it more in class. Okay, so there's some more about your slant asymptote and another picture. So to finish this off, now we have to think about graphing. So the first thing you're going to do on your graph is punch in where your asymptotes are. So let's say you had one here and you had one here. Then you're going to think about the end behavior in each zone. Okay. So what that means is, so if we're here in, let's say we pick a number on either side. So let's say we pick a number and we know we're in this zone. So it's the negative x zone. So you ask yourself, okay, as x gets really negative, so it gets larger in the negative, what happens to the function? It's either going to approach negative infinity, or it's going to approach your asymptote. So you think about your end behavior. So let's say this one is end behavior on the asymptote. And then you look at, okay, well, as x gets closer to our vertical asymptote, what happens? Say, so it goes to infinity. And then just pick a number in between if you don't have an intercept there, so you can kind of get an idea. And then my guess, given my made-up example that has no problems, your other one would look like that. So graphing is simply taking all the available information, your x-intercepts, your y-intercepts, your asymptotes, putting them on a graph, and then generally sketching what the function would look like. So I'll cover this one in class. So in this video, we looked at how to find intercepts of rational functions, how to find horizontal asymptotes, vertical asymptotes, slant asymptotes. Talked a little bit about finding domain and range and how to sketch the functions. If the slant asymptotes and polynomial long division is something that is just completely new to you, I recommend, I'll try to post a video that I found, or a link I found in additional resources. But if you just Google polynomial long division, there's a really good Mathis fun explanation of how to do it.